Lesson part of lesson 2 in unit 1, so 1.2, constructing patterns. Hopefully you guys used Lift to get here. All right, here we go. So here we're given two circles. They each have centers A for this circle on the left and center B for this circle on the right. So we will talk about these in terms of circle A and circle B. Okay, the radius for each one of these is a distance from A to B. Notice that they share that radius, which means that the two circles have to be exactly the same size. Based on this diagram, it says, explain how you know each statement is true. The length of segment EA is equal to the length of segment EB. EA here and EB here. How do we know that they're the same length? Well, if the two circles are the same size, then any radius has to be the same length. So here, for circle A, EA is a radius of circle A. And here, for circle B, BE is a radius of circle B. So if the two circles are the same size, then that means that the two radiuses, or the radii, are the same length. All right, next one up. Triangle ABF is equilateral. Okay, ABF, that's this one down here. So how do we know that that's equilateral? First of all, equilateral means equal sides. So equilateral means that all three of these sides have to be equal. How do we know that that's true? Well, we already established that this circle, circle B, and circle A have to be the same size. That means that all the radiuses for each one of those circles have to be the same. So AF is a radius for circle A, AB is a radius for circle A, and BA is a radius for circle B, and BF is a radius for circle B. Since all three of these radii have to be the same length because the two circles are the same size, then therefore this triangle ABF has to be equilateral. So let's see here. Okay, AB is 1/3 of CD. AB is 1/3 of CD. Okay, so that means that the distance from C to D could be split into three equal parts. CA, AB, and BD. How do I know that they're all the same length? Well, again, AC is a radius for circle A. AB is a radius for circle A. And BA is a radius for circle B. And BD is a radius for circle B. Because the two circles are the same size, they have the same length radius. So AC has to be the same length as AB. And it also has to be the same length as BD. So if you have three equal pieces and AB is one of them, then AB is 1/3 of CD in terms of the length. Next one, CB is equal to DA. Okay, CB, we talked about this in class. CB is a diameter. It goes across a circle from one side to the other, and it goes through the radius. So it's a line segment that goes from one edge of the circle through the center to the other. And it's just like having two radiuses or two radii stuck together, right? CA and then AB. Okay, that's two radiuses that go together to make this diameter. Now if we look at DA, looking at DA, same thing there, right? AB is a radius for circle B, or BA is, and then BD is, right? So again, this is a diameter from A to D. It goes across the circle and goes through the middle. That means that since these two circles are exactly the same size, the diameters are also the same size. All right, next one. Use the straight edge and compass moves to build your own pattern using the circle and radius in the applet below as a place to start. As you make your pattern, record each move in the space below. Use precise vocabulary so someone can make a perfect copy without seeing the original. Include instructions about how to shade or color your pattern. Okay, the thing that they are talking about here is take a look at this one. It should give us a... Oh, nope, it's not giving us that video. Okay. We're not going to be able to recreate that pattern. So it's okay. You don't need to worry about this task here or the ones underneath it. All right, we're not going to be able to get there. All right, so that's it for the lesson part. And then here's the practice problems, which you guys are onto on your own. All right.